Assalamualaikum and very good afternoon, everyone. Welcome to Architect Talk 2021. Today, we'll talk about roofing. My name is Zaidi from United Citizens Sdn Berhad. We are the manufacturer of metal roofing and cladding since 1993. We will talk about a roofing system for aviation industry today. But I'm not the only one going to talk today. I have one good friend who are architects who have the privilege to actually completed two projects for aviation industry in Malaysia itself. So he will share his needs in the expectation of an architect, and we as a system provider will try to provide the in-depth what are the needs in the industry for everyone information at the moment. So I would like to invite Encik Rafi from Linear Architects, who has been my good friend for the past 20 years. So we have been up and down, and we have helped each other in our projects and industry that is very challenging nowadays. But the most important thing, as I said, as a system provider, we need to hear what are the clients and the architect expectation uh, on their design and the industry itself. So without further ado, I would like to invite Encik Rafi to have some say or some thought or some advice in this system for roofing in the aviation industry that he has been faced and expected in the sense of architect point of view. Encik Rafi, welcome to the Architect 2021 talk.
Hi, Encik Zaidi. Hi, everyone. Good afternoon, and thank you again to Encik Zaidi for the wonderful opening words for today's webinar. Ladies and gentlemen, today air travel via airport terminal is by far the fastest way to get people around the world. Millions of people fly for international or domestic destination. People travel by air, whether for leisure or for business purposes per se. And while travel mostly can be fun traveling experience, it can also sometimes be a frustrating journey if airport terminal is not properly planned at early stage. Ladies and gentlemen, with a good airport design approach, together with an effective terminal layout that equally match to the airport needs, may significantly improve airport efficiency by cutting down passengers' waiting time and walking time in the terminal. Therefore, with this in mind, in return, it may give passengers a comfort feelings and good experience while being in the airport terminal. So, ladies and gentlemen, in today's webinar, the topic will focus only on the roofing system for the aviation industry, building primarily on the design consideration, two, the challenge faced by the industrial player to fulfill the needs, the design needs, and the technical requirement. So we don't have to compromise the form and the functionality of the airport terminals. Ladies and gentlemen, later in this webinar, after we talk about the topic on the design consideration and technical requirement when choosing metal roofing for airport terminal, I shall share a case study for two airport terminal development completed by Linear Architect in Malaysia, which are first the Sultan Abdul Halim Airport, Alustar in Kedah, and the next one is the Malacca International Airport, Batu Berendam in Malacca. Ladies and gentlemen, there are three subject matters to consider when choosing metal roof system for airport terminal building. One, to meet the architectural design requirement. Second, to meet the technical performance requirements. And last but not least, able to fulfill client requirements. Okay, first, let's go to the use of metal roof system to meet the architectural design requirements. These are the consideration to look at, as you see on the slides. First, the roof system is able to adapt towards architects' design needs. either it can be tapered, curved, or straight design roof. In other words, metal roof is flexible to design needs and to the architect's design intent. Second, it able to cater to a low roof pitch angle design. In other words, virtually flat as minimum as to 1.5 degree pitch in some cases. Third, the metal roof deck is capable to continuously span with less connection or joints. With less joints means have high insecurity and 100% watertight. Number four, another point that to look at is aesthetically. It has a sleek, bold, expressive look, but yet it have a good roof build-up system, and the important thing is economical. The next point I want to bring is that the roof is a lightweight system, but give a strong, rigid, and lasting appearance. The next point, the sixth point that I want to bring is that the roof system is able to do a non-puncturing method roof system. In other words, no screws or boltless, which minimize leakage and thus avoid disturbance to terminals operation and safety toward passengers. Another point is that the metal roof system is able to maximize the span between each roof purlin, which in return optimize the design value for money. Its total weight of roofing system versus a steel structure design. Okay, on this point, the lightweight of roofing system able to reduce the cost on the terminal substructure. Another subject area to consider under the design requirement when choosing a metal roof are quite important things to look at. It's able to adapt toward adverse weather condition, and last but not least, on the consideration to meet the architectural design requirement is to have a strong profile to resist wind uplifting. Ladies and gentlemen, now we go to the next subject, second subject matters to consider when choosing a metal roof system for airport terminal building, which is to meet the technical performance requirement, which I put here 3 points. First, a roof build-up system that meets sound acoustic performance, which means the sound transmission coefficient, or in the short form, STC value for airport terminal. STC is a rating of how well a building partitions decrease or reduce the airborne sound. It is to rate the interior partition, exterior wall, as well as the roof system configuration. Later, Encik Zaidi shall further explain on the STC. Well, the next point that I need to bring on the technical performance requirement for airport terminal is a roof build-up system that able to provide a lower heat transfer U value. Another point to look at is that a roof build-up system must give 100% water tightness roof system. With this, the right performance and configuration on roof build-up shall able to bring comfort and safety towards the passenger, and also able to minimize the operation cost to building operator, especially on the electricity consumption. And finally, the third subject matters to consider when choosing metal roof system for airport terminal building is the use of metal roof system that able to fulfill client's requirement. Here, I put 3 points to look at. First, it able to optimize the roof system design value for money. In other words, the right method and choice with optimum design approach contribute to the economical and less weightage of roof system. Second point that I want to bring up is that a product warranty from manufacturers, suppliers, and installer, which is it give a reliable, trusted source. These are things that the client looking at too. And last but not least, another point that I want to bring up is that to have a low maintenance roof system. Ladies and gentlemen, with three subject matters to consider when choosing metal roof system for airport terminal, which are the architect design intent, client requirements, together with the technical performance, the benefit in return will give 1. Save energy, 2. Give comfort, 3. Provide safety and security, 4. Minimize the maintenance, and lastly, optimize the design value for money. Ladies and gentlemen, on the next slide, I shall share 2 cases study of airport terminal development completed by our office, Linear Architects in Malaysia. First, as you see on the slide, the development of Sultan Abdul Halim Airport at Alustar, Kedah. Completed in the end year of 2005, development executed into 4 phases. The phase 1, earthworks and runway construction. Phase 2, construction of air traffic control tower. Phase 3, construction of piling works for all buildings. And phase 4, construction of main terminal building, transfer corridor building, VVIP annex building, airport fire rescue service building, central utility building, landscape and infrastructures. Ladies and gentlemen, from the aerial view of the Sultan Abdul Halim Airport Terminal, as you can see on the slide, we can see a various roof profile, shapes, and pitch angle which was designed by the architects. For example, the main terminal building has 2 different pitch roof angle. Transfer corridor is extremely curved in shape, and the entrance porch too have a different shape and profile. And this has give a challenge to choose the right type of roof profile, method of construction, consideration on the design performance. In summary, roof system using metal, I can say here, is able to fulfill architecture design intent during the course of design development as well as during construction. Ladies and gentlemen, on the next slides, I will share about a photo of VVIP Annex building at the Sultan Abdul Halim Airport Terminal. Here, the architect have designed the roof shape totally different entity and exclusivity compared with other buildings, as you can say by the name VVIP itself. So an approach by the architect is to design like an eggshell shaped roof was realized, and this has given a challenge to architects to choose the right type of roof profile and method of construction. However, again, with the flexibility of metal roof able to shape and constructed in tapered curve without have to compromise the performance of the build-up roof system, and importantly, give 100% watertight, has resulted a very unique design, and the challenge is resolvable due to the flexibility of the metal itself. Ladies and gentlemen, on the next slides, I will show is the photo of transfer corridor building at the Sultan Abdul Halim Airport Terminal. Here, again, the architect have designed the roof shape in an extreme curve in many ways. And the roof surface, if you look it properly, has a pattern like a herringbone design. So, and this also have given a challenge to architects to choose the right type of roof profile and method of construction. And again, Again, I said a flexibility of a metal roof able to shape and constructed in curved shape without have to compromise the performance of the built-up roof system. And again, it gives 100% watertight and has resulted a unique building facade. When you approach or when you landed to the Lapangan Terbang Sultan Abdul Halim. Ladies and gentlemen, now on the next slide, I will share the second case study of the airport terminal development completed by linear architects in Malaysia, which is the development of Batu Berendam in Melaka, completed in the end year of second quarter of year 2009. The construction consists of development of the new main terminal building, the air traffic control tower, airport fire rescue service building, AFRS, meteorology building, airport runway, and also the landscape and infrastructure. Ladies and gentlemen, this is the aerial photo of the Melaka International Airport Terminal. The architect's design approach on the roof is to have a dynamic, sleek, strong, bold outlook, like an aircraft wing, and at the same time having a low-pitch roof angle. With this design intent by the architects, it has given a challenge to choose the right type of the roof system, and in summary, metal roof system is the right method and choice to fulfill the architect's design intent during the course of design development as well during the construction. Metal roof is able to meet architectural design need, able to do a non-puncturing metal roof system. In other words, no screw or bolts. Metal roof system also able to accommodate a long span, and at the same time, it lightweight too. It's not too heavy. Another point is that the metal roof system is able to meet the technical performance requirement, like I said earlier in the slide. The next point I want to bring again here is that the importance of 100% water tightness and able to resist wind uplifting. As you know, everybody, airport area or airport complex normally in the surrounding area have less trees and is open to a heavy wind. And lastly is that with the metal roof system, it able to realize the architect's needs, which is to give a sleek, bold outlook like an aircraft wing. On the next slide shows the side view of the main terminal building of the international airport. Like I said again, it able to meet the architect's design needs. And the next slide shows the closer look of the terminal entrance porch, which have a long, wide roof span that able to cater a multiple vehicle lane below the roof. Ladies and gentlemen, as a summary, for Melaka International Airport, Batu Berendam Melaka, and Sultan Abdul Halim Airport, Alustar Kedah, with the good airport design approach and planning, together with a thoughtful usage of material choice, such as the type of roofing system in airport terminal, can vastly contribute to the improved passenger comfort and experience inside the building, as well as maximizing the space functionality. So with that slide, I will say thank you everybody for listening to my presentation. Well, for information, you can contact us at on the screen below and the screen in front of you. And now I will pass the next session to Encik Zaidi for the next session of presentation. Encik Zaidi.
Thank you very much, Rafi. Wow, such an in-depth. I just remember some of the sleepless night that we have during that particular project.
Yes.
couldn't lose weight, but yeah, get some white hair at the end. Uh, Moral of the
Yes, you're
story, listen to the architect. Moral of the story, listen to the architect. Ladies and gentlemen, thank you, Rafi, again for the presentation.
welcome.
Very resourceful and very informative to us as a roofing industry. Uh, Now, I would like to present my slide on the part of my session. So let's go in depth. What is a roofing system for aviation industry that required at the moment? All right, we have few design criteria that we are supposed to meet. I think there's four major things that I want to touch in these particular presentations. I don't want to go to things are not important or maybe too detailed. Number one, as what Rafi was saying, that to meet architectural design, this is very important. Don't change, don't move, don't be too smart against them. So the other thing that Rafi also mentioned just now, that's a low pitch roof, that how you're going to work with low pitch roof. And most of architect design work based on low pitch roof because most of the airports or the industry buildings are huge, long, and wide. The third one that we're going to talk about today is actually a conceal fixing roof, which is the best system that you should choose during your design, and a system that must be in place for such important building. Last and not least, we're going to talk about design and acoustic for acoustic and thermal performance. As again, like Rafi mentioned, very important in the design of the airport. Let's start with the mid architect design. So most architecture design nowadays for the airport, they're going to have a very normal straight roof, a very low pitch, as I said, because it's huge, and also a curve. And I would write there smooth curve. The reason that the smooth curve actually gave the in depth or the looks of the building very pleasant. And also most of the time we have the third one, a tapered straight, which is what we call it curve on plan, uh, which ability to tapered roof, then you eliminate the use of flashing and capping. And also tapered curve, just like Rafi mentioned on the VVIP building, where you require that kind of ability to do that kind of shape. And also concave and convex, double curvature. This is normally designed for most architect like at this moment. All right. Again, this is the Kawa standing seam on Malacca Airport, the project that we done with Encik Rafi, which is a very flat 2-degree pitch at 60-meter length. That's for example. Then we also have the Area Sultan Abdul Halim Airport in Kedah, which is a smooth curve with double curvature, and also have a very good STC and U value when we talk about towards the end. This is a smooth curve standing seam where in China Island building. So architect would like to see something that is smooth, you don't have this crimping like factory look alike. So this is a better choice for all this design in the airport or industries. Another photos of curve roofing on a building. I think just to let you know that most of the curve or long span is clearly because there are no joints and also no puncturing through, and also it will have a very good flow of water at the end on the design itself. Okay, low pitch roof. I think as mentioned by Encik Rafi just now, they are very important to have a low pitch roof, make it virtually flat. The reason that you have to do this thing, that you must be able to use a product that actually able to take care of the amount of water that flow on the roof itself before it reach to the gutters or beyond beyond the roof itself. All right. So low pitch. This is the section of actually the Malacca Airport that sorry, hold on, yeah. Okay, this is the section of a low pitch roof of Malacca Airport. As you know, it's a 3-degree pitch. It's actually span around 60 meters, if I'm not wrong, I remember correctly. So it has to able to take the amount of water in Malacca itself when it's rain, and before it move to the gutter or the water collections. I really this smooth curve standing shape. I put there multiple curvature dimension because this is one of the design that in Sultan Hasanuddin International Airport. When they design a conical shape, if you notice that the photos, every 5 pieces, we have to change the radius just to meet the design of the architect. Moral of the story, listen to the architect. All right. So continuous long length roof. Most of the time, architect don't like this roof that they design to have joints or a lot of cuttings, that kind of things. It is to eliminate the possibility of leaking as much as possible. And we have to produce one thing like one single piece eave to eave, what we call it. Right. So this is how it looks when people just realize that eh, how could you hold on here, what happened? All right. Okay, back a bit. All right. Everybody was asking once in a while that how did you manage to do long length roof at 96 meters, 60 meters, 161 meters. This is how you look at the site, and you have to bring the machine at the site and produce the roof at the roof level in this case for the length that required for the particular building. All right, this is how it looked like. Forget about the difficulties, but this is how it looked like at the end. At this building, if I'm not wrong, is about 92 meter in length from eave to eave, that without any joints or in one piece roofing system. I see another example of site forming. Sorry. Right. Okay, this is an example that what we said is that no, most of the time site forming are eliminating the end lap, that you have a one full piece of roof, again eliminate 100% possibility of leaking. Okay, this one is complete. Well, when we talk about roofing, everybody we have a few system that I think what I want to talk about at this industry. We're talking about conceal fixing, or most of the time people say boltless system. I'm not sure what the boltless is about. We use bolt, but it's not boltless. Uh, there are few criteria that you should look into. One, what we call it standing seam. Uh, some of the cases we call it lock sim. It depends on the building and the product that we're going to use uh, for the particular building. And most of the time, when you have a very low pitch, you're going to have a very deep corrugation, and or you call it high rip single pan roof. Let's go to one by one. Yeah. So one of the item, we call it on our side in United Season or Kawa, we call it Kawa standing seam. Actually is a non-puncturing boltless roof system, which is there are no puncturing through of any connection for the roof. It's a lock and seam to ensure watertight roofing. It's also light but strong. We have done this roof up to 122 meters, in a certain project. It works well with a heavy rainfall or tropical country like us, or torrential rain that we have right now. We do have flooded yesterday. Yeah. Then, yeah, the other strong roof that we have actually is a Kawa Loxin. This is for the supporting building like hangars and that kind of building. So it has a very bold and deep corrugation to make sure it able to span and also to cater for the rainfall that we have at the moment. Last but not least, one of the deepest that we have, one of the, sorry, I saw the jump. Okay, with one of the deepest that we have, we call it Kawa R500 lock sim. You have about 160 depth of corrugation. We have actually successfully installed a project at 161 meter at 1.5 degree pitch. And to make things even more interesting, the supporting, because the strength of the product, the support for the particular building is every 5 meters. All right, I think this is most important thing, and we have a lot of misconceptions of this particular subject. The one is the acoustic performance, the other one is the heat performance. I used to be asked that whether which one is more important. So basically, both are important. I think to make it a very simple terminology, most of the time, if you have acoustic performance, you automatically does have your heat performance. But of course, it has to see how you actually install the system properly and get things done properly with a good calculation and testing. Let's go one by one. Now, everybody know that in the airport, like Rafi was saying, that it has to be a good vibe. You're waiting for your flight, not to be noisy and that kind of thing. So let's understand how sounds travel. So sounds travel three-dimensional, but what you can do, that there are one that you can actually reflect. The many type of roof reflection, meaning to say that it can reflect on a hard surface, which is you create an echo, which is not so nice when you can't hear actually your announcement at the airport. The other one is absorption, where actually you absorb the sound. Uh, a good example is that in your cinema. Diffusion, actually you actually diffuse surface does not directly absorb the sound and also not reflect, and the sound is just dispersed by itself. So it's a bit of a technical thing, but basically you know where I'm come from. Right. So let's understand how in the airport or in the aviation building works. If you are in the airport, if you don't have a very good insulation or good system on your STC, this is what happened. Let's extend the sound, if you can hear properly. Yeah, this is most of the time that the when aircraft taking off, they are creating about 900 dB to 110 dB of sound. Yeah, let's see what is it like. It's a very high frequency sound, right? This is the outside. Most of the time you don't hear it in the inside. But imagine if your airport does not have an insulation. This is what you'll be hearing from the inside, right? I've been some of the aircraft will be taking off about 90 seconds apart. It's going to be very noisy. But if you have a good insulation, in this case, STC 43, 41 here, but in the Malacca Airport and Kedah Airport, Rafi have required STC 43, which is, let's see, this is the original sound of the taking off, right? Then this is the sound when you're in the airport. It reduces a lot of sounds, and you're going to have a comfort in the airport, even your flight delay, which is everybody hate, right? So the other thing that we're going to talk about, sound absorption. When you are in the airport, there are lot of announcements, a lot of information they're going to give. Anything. Imagine if your airport have not good insulation, we don't absorb the sound. This is how the announcement will sounds like if without any absorption being done by the ceiling or the roof side.
In doing so, he became the founder of modern acoustical engineering.
Right, there'll be a lot of echoes, so some of them must miss the flight, that kind of thing. But you have a good insulation on the roof, because roof is the biggest element in the building. So you actually can have a perforated seal deck and do absorb the sound. And where is my yeah, you would be something like this.
In doing so, he became the founder of modern acoustical engineering. He went on to design
Right.
the
This is what we call it sound absorption requirement in a building of airports. It's very important that you not to miss your flight, not listening to the announcement. Yeah. Okay. The other subject that people talk about sound absorption. How does it work? Basically, it's quite easy. You're gonna have sounds like 80 dB on one side, on my left, and then you have a SCC 39 door, what we call it, sound transmission class or sound transmission coefficient 39. Then once you're the receiving room, where you're at the end of the room, you're going to have about 41 dB, which is less uh, loud that as you could think of. This is a simple concept or example. That's how sounds work. Yeah. Okay. So in order for you to have that STC value, the sounds work very unique. In example for this one, we have insul, what we call it, insul programming, that they can actually simulate or calculate the potential sound that you're gonna STC that you're gonna have. We have a STC 43 built up here. You're gonna have about a roof. You're gonna have a fiber cement. You're gonna have a uncompressed rock wool, in this case 60 kg at 75 mm, and you can have another layer of roof at the bottom. So it will give you more or less something like SCC 43, but in actual test probably plus minus 3 or 4. It should not be a difficult thing to get. Just a simple example that how you create a system build up. Okay, of course, acoustic system. Also, you have to test a certain standard. In our case, we always use ISO 140 slash 3 part 3. So this is what we call it, a laboratory measurement of airborne sound insulation of building elements. This is a thank you from the Faculty of Architecture, Planning and Surveying, UiTM Shalam, that we have worked with them. The other part that you have to follow, actually, ISO 7171-1 part 1, airborne sound insulation in a building for interior building element to determine the RW or sound. All right. So system acoustic test, actually, when you come to a build-up system, you actually have a system build-up. Then you're going to have a chamber. Then you're going to do a mock-up, actual mock-up. Then the sound is tested, and for you to get the actual result when you end. Right. The next thing that we do, as I said, the SCC will come with the U value, but everybody was confused what is the U value. And lately I have seen a specification that specified the U value on a product. Uh, I mean insulation product. It is not the way it works. I mean, if you look, the value is a measurement to express the heat loss factor of a material. So the value U value normally come in a unit of watt per meter square Kelvin or Celsius. In this case, a bit of formula here and there. But the thing is, the U value is calculated as a system. You don't calculate a value is in a single product. So let's get a bit more informative on this one. This is one of the calculation of U value, which is basically there's no U value. Before I forgot, the bigger the number on U value, the no good you are. All right. So doesn't mean the bigger the better, but the bigger the number is not good. Okay, in this case, you're talking about metal roofing without insulation, where you have your external surface, steel decking, cavity, tesselation, plasterboard, and that kind of internal space. So most of the time, that when you do a calculation, the thickness are important, and the R value is important. In this case, the thermal conductivity, depending on the product or the system that you use. A quick one, this uh, calculation has created a 3.205 watt per meter square Kelvin, which is no good. It's a zero insulation. You are depending on your plasterboard liner at 13 mm, which is not good. You're going to be very hot in your building, in your room, in the airport or whatsoever. So again, let's go back to metal roofing insulation. If you know that you have a metal roofing, you have insulations, and you have liners at the bottom, it gives you a lot of thermal resistance against heat outside the building. Let's go back. Let's how a calculation been done. Okay, this is build up. Actually, is done in Kedah Airport, if I remember correctly, and also Malacca Airport. So what we need to have actually is a very low U value. If example that the item on the top of the calculation and the below the section is inside surface resistance is referred to MS1525. Basically, it's constant, and you have a roof at 0.6, and you have a double-sided aluminum foil, and we do have a insulation fiber at 100 thick at 40 kg. We use a cement board to reduce the height of the build-up, just to get the numbers right. So the idea is to get as low as possible with minimum cost to some extent. This is a technique that everybody have to learn at the end of the day with the experience that we have. So in Malacca Airport and Kedah Airport, the U value at 0.331. We're talking about just now 3 point something against 0.331. This is a good U value, and it also gives you a very good sense of STC level towards end of the design. Okay, let's share a bit more. All right, so having said that, that is all the things that required in a building of aviation industry. It might not be so much STC in your hangars or whatsoever, but it does have a relationship between all this information that required for that particular industries in this case. I would like to share some of the local aviation project reference that we have done in Malaysia, to have a fair share. I think all the way from the south to the north and towards the east, we do have some shares in some of the project. So one of the project, I mean, we started from the early slide, we have somewhere in Senai, and we move up to Malacca. Then we do involved in Sultan Azlan Shah Airport in Ipoh. You know, if you go up a bit, this is towards the east, Sandakan, I think the most east. I think we have done this project again with a concealed physics system, a good U value and SCC value. This is another angle of the project. Okay, this is the, again, I think the hangar is part of aviation industry. You're gonna have a very long span, long roof, a big area, huge amount of water gonna go through your roof. You know, you need a very good concealed facing system for your building. So this is a mass cargo during KLIA that we did. This is part of the support building in KLIA. Another hangars. I love to say this most of the time, that at one point Airbus A380 hangar are the world widest columnless hangar in the world without a support in the center, which is at the opening at end to end is about 230 meters wide. Yeah, just to be proud of Malaysian. And mass complex catering building, where's your food when you fly? This is being cooked over here. We do have a fair share of overseas aviation project reference photos. In this case, the first one is quite a challenging part, the Suai Airport in Timor-Leste. I guess some of you don't know even know where this Timor-Leste is on the east of Bali or something like that. So it is very challenging for us to use this thing to do this project at that point of time. Another building of that particular airport, Timor-Leste. And this is the China Airline building in Hawan. They use the metal deck as part of the wall, and with good insulation, smoke curve. Phnom Penh International Airport. Basically, in Cambodia, we do two airports. Actually, Phnom Penh, the main capital city of Cambodia, and also we have a tourist city of what you call Siem Reap. So we have the experience to go there with all these requirements from the international sounds and also the U value required by the architect at the point of time. That's all for now. Thank you very much to be with me. Should you need any more information, do actually scan the QR code. Can contact us anytime, and feel free to drop us an email or any way of connect that you can connect to us. That will be the end of my presentation. I would like thank you to Rafi. Are you in with me, Rafi?
Hi, how are you? Fine, thank you.
Rafi,
Uh,
thank you very much. I
yeah,
think
yeah.
last before I forgot, in United Season or in most of our project, we are using thin carbon material from Blue Scoop Steel, or if it's in overseas, we have a Blue Scoop Thailand, Blue Scoop Indonesia. In this case, it's a very good material that we have been associated with on all our project. And just to comment, Rafi, I was impressed that during the Kedah Airport, you chose red color to be the roof because you have a green environment. Suddenly you have one red building inside in the center of the Sawapadi or kind of thing.
Yeah. Thank you. Yeah.
Thank you very
It give
much.
it give
Thank you very much,
it
Rafi.
give it give outstandings towards the overall landscape of the Kedah Airport, which is all green with a paddy field. Yeah. Thank you.
Absolutely, absolutely. I would like to thank you again, Rafi, to being with us
Yes,
today,
welcome.
and see you guys soon. Thank you very
Okay.
much.
Okay, I hope with this topic presented today, we give some contribution in terms of the design requirements and knowledge in the roofing system for aviation industry. Thank you again, and hope to see you guys again. Bye.
See you soon. Bye bye.
See you soon. Bye.